Did you know that by using list compressions, you can make your code more concise, faster to execute, and easier to read? So we have an example here where we have a list of numbers in this variable called numbers, and we want to convert these numbers into squares of their equivalent. So for example, you have 1 multiplied by 1, which would be giving a square number of 1. 2 multiplied by 2, which would give 4. 3 multiplied by 3 would give 9. So we want to store those within this variable called squares. And this would be the list of results of those squared numbers. So we have the following loop to achieve this for x in numbers. So this is the iterable, and this is the item, individual item, and this is the list of numbers. So for each item, 1, 2, 3, for example, we want to do some processing, which is done within here. So within these squares, a variable, which is a list of numbers in this case, we want to append the following, the output of this operation, which is x multiplied by x. And as this is a for loop, each element is processed in turn. And then finally, we print the results, which should look like 1, 4, 9, 16, because these are the squared of the numbers in the first list. So this is one way to do this, but of course this code is neither concise, neither it is fast to run, and it is harder to read. So if I run this, this is the output we get. If I go here and then go here and run the file. And as you can see, we now have the square of the numbers 1, 4, 9, 16, 25. So how do you do this in a more concise way? So how would we make our code more concise, faster to run, and easier to read? So we can use list compressions. So as you can see here, this is the traditional way of doing things, which is using the for x in numbers loop here. So this is the use of the for loop, and without using list compressions. So now, using list compressions, as you can see, we have a situation where we still have the same variable called numbers, which is a list of numbers, and this matches exactly as above. So you can see here, these two match. Next, what we have is another variable to store a list, which would be, in this case, list of numbers. So this is the same as before, but of course, I've just appended underscore comp to it. And as you can see here, now we have square brackets. Now previously square brackets were empty, so they needed to be defined. And where we have defined those is by appending the numbers into that list. But with list compressions, what you do is you do that in one step. So rather than doing it in 2 steps, which is declaring a for loop here and then appending the items to the list, you do it within the square brackets. So here you have x multiplied by x, which is the same as before. So as you can see here, we do the operation x multiplied by x. This is known as the operation within list compression. So the very first thing that you do is what operation would you like to do? So in this instance, we would like to multiply x by x. And as you can see here, the next step is actually the for loop. So for x in numbers. So this is the iterable part. So this is what we are iterating through. So which should be this list of numbers. And we have the x because x refers to each element within here. So as you can imagine looping through a list of items, the first x value would be 1. And 1 times 1 gives you a result of 1, which would then be stored in the squares comp variable. And then the next bit is 2. So the next item is 2. 2 multiplied by 2 gives you 4. So that would be then stored here. So for example, you can see the output here. And so on for 3 times 3, 9, then 9 would be stored. So the result of this operation is actually what gets stored within the squares comp variable. And before, we had to use the append method, but the append actually is not needed here because the results of this operation are automatically implied and stored within the list or for the variable we have defined here. So as you can see, if I run this piece of code here and we get the same output as before, we have 1, 4, 9, which matches as before. So you can see the output is the same for both the for loop and without using list compressions and the for loop using list compressions. So this is one way to create list of items within Python. Let's now run through how list compressions actually work and understand the syntax in more detail. So as you can see, this is the actual syntax for list compressions. So number one, we have the iterable. What is the iterable? It's a sequence of elements like list or a range. So in our instance, we had a list of numbers. So as you can see here, this is the syntax that we have. We have numbers, and this is what is known as iterable. What is it that you want to loop through? So as you can see here, that we have list of numbers that we want to loop through. And then it says in. So yes, of course, in this iterable, we want to get an item. So an item here is basically a number, an element from the list. So for example, 2 could be pulled out, and that would be an element, an item. In our instance, we've called it X. So for X. So for item here, you can call it whatever you wish to call it. And then you have the for part. Okay, which we do to there. So this now matches for X in numbers, for item in iterable. So iterable, remember, is the variable we declared, which is a list of numbers, something you can loop through, a collection of items. And then what you have is the expression. What is an expression? An operation performed on each item. So on each item, an operation performed. So as you can see here, item multiplied by 2. Item dot upper. So in this instance, what we did was X multiplied by X. As you can see here, if you had string characters, you can change them into uppercase. So that would be an operation that could be carried out on a string. But on numbers, what we decided to do was multiply the same number, the same item by itself to get squared of numbers. So we got a square of, for example, number 3. 3 times 3 is 9. So that is known as an operation. But as some of you might have seen, what have I got this? Condition, optional, a filter to include only items that meet a certain criteria. So as you can see here in the syntax, it says after the iterable part, so after this numbers part here, we've got an if condition. So what does that actually mean? Let's understand that in more detail by doing it in our version of the code. So as you can see, let's say we only wanted to get square of numbers from 1 to 5. So if we want to get numbers 5 or less, then what we would do is add an if condition. So the rest of the elements here would not get processed. So the if condition must be at the end in this instance because it's a single if condition that we want to add. So what we would do is in our instance here, we would simply type in if X is less than or equal to 5. So what that would do is it would only process elements from 1 to 5 here. So the item here is less than or equal to 5. So this is the item value, not the index. So it's the item value. So the item must be less than or equal to 5. It's not the index. That's important to understand. It's the value here. So I could have actually called this anything. But as long as it's this value, then we're going to process it less than 5. For example, we could have another element here, which is 2, and that 2 would still get processed because 2 is less than 5. So this is important difference. So it's not based on index. So let's just change that back to 10. And if I run this now, and we still have the old method here, and we have the new one, but this time we've got an if condition. Remember, so this is all done on one line. So if I run this, and as you can see, as expected, it only goes up to 5 because 5 times 5, square of 5 is 25. So how would you do this using the traditional method? Well, what you would have to do is write your if condition here. So you would write if, so x is less than or equal to 5. Then what you would do, indent the code here, and that then if I run this, you again get the same output. Now it's processed. So this is equivalent to what we have done here. So as you can see, the code is much more concise in the list compressions because you only have to do it in one line, while here you have to do it in multiple lines. So you can already see the benefit of using list compressions. And actually, behind the scenes, it runs faster too. And I would say overall easier to read because what you can see is this is the operation that we are carrying out for a loop in this iterable, this list of numbers, something we can loop through for each element in it if the value of that element is less than equal to 5. So if the value of that element is less than equal to 5, do this operation. So this is the easier way to understand list compressions. So hopefully you will now make use of list compressions rather than doing it the traditional long way round of loops. If you liked what I've shown here, please remember to subscribe and like my content.